Imagine that you're measuring the width of your bedroom before you go shopping for wallpaper. You may choose to use meter sticks and count how many fit between the walls. Sure, there may be a bit of space left over, but you may feel this is good enough. For extra precision, you may choose to use a measuring tape, getting the distance correct to a centimetre or even a millimetre. There are devices now that use lasers to get even more precision. The point is, you need to make a decision when you measure something about how precise you want the measurement to be. There are 3 different types of rounding you should be familiar with: the nearest something, decimal places, and significant figures. If 855.74 is rounded to the nearest integer, meaning whole number, we are looking to get rid of any decimals we have in the number. Draw the number on a place value table and draw a line after the ones column. There are 2 numbers that 855.74 could round to, 855 and 856. To decide which it is closer to, we look at the number to the right of the line we drew. This is our decider number. If it is 5 or more, round up. Less than 5, we round down. The number in the tenths column is 7. This is 5 or more, so we will round up to 856. Decimal places count how many digits we want after the decimal point. 1 decimal place will give us 1 digit after the decimal point. 2 decimal places will give us 2, etc. If 855.74 is rounded to 1 decimal place, we will draw a line after the tenths column. There are 2 numbers that 855.74 could round to, 855.7 and 855.8. The number in the hundredths column is 4. This is less than 4, so our number will round to 855.7. Significant figures work in almost the same way as decimal places, but instead of counting from the decimal point, we start from the beginning of the number. 1 significant figure will leave us with 1 digit, 2 significant figures will leave us with 2 digits, etc. We will soon discover, however, that there is something else we need to be careful of. We will draw the line after the 8 in 855.74 because this is the first digit. The decider number is 5, so the 8 will round to a 9, so our answer is 9. No? Imagine someone says that a house is 855.74 centimetres tall. Would you say that's roughly 9 centimetres? The bit we need to remember is that when we round numbers, we do not remove the numbers from the right of the line, we reset them back to 0. 855.74 to 1 significant figure will therefore give us 900.00, but we can remove the zeros after the decimal point because these are not placeholders, so our answer is 900. Imagine that you're buying 3 tubes of toothpaste at £3.99 each. To work out the total, you would likely do 3 times 4 to estimate the price at roughly £12. This is estimating. In maths, it's generally acceptable if there are no other factors at play to round numbers to 1 significant figure when estimating. So let's estimate the answer to this calculation. 2.7 times 17.9, all of that divided by 0.547. We start by rounding each number to 1 significant figure. 2.7 will become 3, 17.9 will become 18, and 0.547 will round to 0.5. We now have this 3 times 20 over 0.5. This is much easier for us to do in our head. 3 times 20 is 60. 60 divided by half is 120. It is always important to keep track of the effects of our estimating. Either our number will be lower than the correct answer or higher than it. The real answer to the question you can see is 96.66, so our answer is an overestimate. If we didn't have a calculator, we can see how we rounded each number. The numerators were both rounded up and the denominator was rounded down. So our estimate will be larger than the real answer, so this is what we call an overestimate. The purpose of estimation is to give us a quick way to work out roughly what the answer is. Rounding a square root to 1 significant figure won't really help us. If you do not know what the square root of 28 is in your head, chances are you don't know what the square root of 30 is. With square roots, it's more helpful to round to the nearest square number. 28 is very close to 25, and the square root of 25 is 5. Very rarely you may be asked to make an estimate with pi. If you have a calculator, pi is assumed to be estimated to 3.14. If you don't, then 3 should be good enough. Note though, it's always better to leave your answer in terms of pi if you can. When we come across numbers that have been rounded, it's often important to know what the numbers could have been before the rounding. A common way of doing this is with error intervals. Imagine 24,000 people attended a music festival, but this number was rounded to the nearest thousand. To find the error interval, imagine what the next number down that it could have rounded to. This would have been 23,000. Our minimum value will be halfway between these numbers, so 23,500. Now imagine the next number up it could have been rounded to. This would have been 25,000, so our maximum value will be halfway between these numbers, or 24,500. We can now write an inequality to show the range that the original number could have been in. It could have been equal to 23,500, but it could not have been equal to 24,500, otherwise it would round it up to 25,000. Our error interval will therefore be n is greater than or equal to 23,500, but less than 24,500. We may need to find an error interval for a number that has been truncated and not rounded. When a number has been truncated, the end of the number has simply been chopped off. Imagine a calculator has a note covering the last two digits of a 5-digit number. We can see that the first three digits are 408. The lowest possible digits that could be hiding under the note are 0 and 0. This makes our lowest value 40,800. The largest digits are 9 and 9, making our largest value 40,899. Our error interval will therefore be n is greater than or equal to 40,800 but less than 40,899. The minimum and maximum values are known as the lower and upper bounds. We can use bounds in calculations to find the minimum and maximum answers. Imagine we have a rectangle that is 4 centimeters by 3 centimeters, each rounded to one significant figure. To find the maximum perimeter of the rectangle, we can add the maximum amounts from each measurement. We will therefore use the upper bound of the 4 centimeters, which will be 4.5 centimeters, and the upper bound of the 3 centimeters, which will be 3.5 centimeters. Note, however, quite rightly students point out that I should use 3.49 recurring. 3.49 recurring is actually the same as 3.5. The maximum perimeter will be 2 times 3.5 plus 4.5, which is 16 centimeters. If we wanted to find the lowest the area could be, we can use the lower bounds, 2.5 times 3.5, which will equal 8.75 centimeters squared. Whenever we use subtraction or division, we must think about what we want to be an upper bound and what we want to be a lower bound. Imagine we have a different rectangle that has an area of 200 meters squared and a length of 30 meters, each to one significant figure. To find the width, we would do the area divided by the length, but to find the minimum width, we will not want to use the lower bound for each number. To minimize an answer in a division, we want to do the smallest possible number divided by the largest possible number. In other words, lower bound divided by upper bound, or 150 divided by 35, which equals 4.3 meters.